Okay, please let me know if anyone can see my screen.
Yeah, it's visible.
Yeah, thank you. Okay, so first of all, I would like to introduce myself. So I'm Mohammad Mohsin Ansari, and I have joined Prama as a senior software engineer. So it's like 1 month and 1 week since I have joined the Prama. So let's start with my presentation. So my topic for the presentation is Spring and AWS. So these two technologies are distinct, but they are complementary technologies. Now the question is that how Spring and AWS complement each other. So basically, there are various points on which we can say that Spring and AWS complement each other. Actually, AWS works with various technologies and various programming languages, but I'm a Spring developer, so there are 3 points on which I can describe. So first is integration with AWS service. So the Spring frameworks provide us various libraries like AWS SDK, using which we can connect or interact with multiple AWS services like S3, RDS, DynamoDB, SQS, SNS, and all of the services. So it provides us the SDK by which we can programmatically connect with these AWS services. Another point is that the deployment on AWS, we like with a Spring application, we can develop various types of applications, Java-based applications, and these all are deployable on AWS services. And when we talk about the microservices, so we have two very good services provided by AWS, which is EKS and ECS. So which gives a very good support for the microservices, and we can deploy those containerized based applications on these two services. So I have divided my presentation into 4 parts. So in the first part, I will be demonstrating how I can means how we can deploy the Spring Boot application on the Elastic Compute Cloud, that is EC2, using the S3 bucket. In the second section, I will be demonstrating how we can deploy the Spring Boot application on the Elastic Bean Stack using the S3 bucket. In the third section, I will demonstrate how we can deploy the Spring Boot application on the Elastic Container Service, ECS, using the ECR. So ECR is just like the Docker Hub. We can use this as a registry. We can save our images here. And the last part is the question section. Means whatever I have presented, you can ask any question from me. So let's start with the presentation. So the first part is I'll demonstrate how Spring Boot application can be deployed on the Elastic Compute Cloud, that is EC2, using the S3 bucket. So first of all, I would like to explain that what is EC2 and what is S3. So when we talk of the EC2, so EC2 actually it is a virtual machine, and we can use this virtual machine to deploy our applications. And this virtual machine can be of any platform. It can be of the Linux platform, it can be of the Windows platform, Mac platform. And then we have the S3 bucket. The S3 bucket is used for saving the objects. You can save your objects here in the S3 bucket. So let's start with the demonstration. So let me log in into my account. Okay, so here is a small Spring Boot application which I have created. So actually, this is a very small application, Spring Boot application which I have created, which is consuming the ChatGPT API, and whatever we ask in the prompt, it gets us its answer from the chat GPT. So I have used GPT 3.5 turbo model for this application, and I'm using the free version of API in this application. So I will be deploying this application onto the EC2 using the S3 bucket. Okay, so this is the console home where we can see that in the search option we can search for the services. There are lots of services in the uh, which the AWS provides. So this EC2 service, I have selected it. So this is the EC2 dashboard, and in this EC2 dashboard, we can see that it gives us a overview of whole EC2 service. So like there are regions also. So I'm in the Asia Pacific region, Mumbai. So here we can see that we have 0 instances running. We have 0 load balancers, two security groups, and elastic IPs, and scaling groups. So there are a lot of features in the EC2. So let's start with the instances. So we do not have any instances running. So let's launch an instance. So this is our first instance. So let's name it my Rama EC2 instance. So this is the name of the instance, or you can say name of the virtual machine. Then here we get options for selecting the OS. So we have lots of options. So let's select the Ubuntu. So I have selected this free tier, so it is not chargeable. Then there are lots of instance types, means which is based on the CPU usage and memory usage. So I have selected this default. This is also a free tier. Then we have option to select the key pair. We can select or we can ignore it. Then in the network setting, this is a security group selection. This security group selection is very important because it acts like a firewall to our virtual machine. So it means what traffic we are allowing into our EC2 instance is based on this security group. So we have to configure it. I have already created one security group. So let's select that. And let's launch this instance. Okay, it's launched. View all instance. So here we can see that our instance is launched and it is in the pending state. Let's refresh it. So it will take a couple of minutes and it will change its state from pending to running. Yeah, so it's running. Now the question is, we have created this EC2 instance, or you can say that we have created this virtual machine. Now, how we can connect with this EC2 instance? So there are multiple ways by which we can connect with this EC2 instance. The one way which the AWS provide us using this connect, we can also use the SSH secure shell to connect from our local machine, but I'm using this connect feature. So it is a cloud shell. So it is establishing connection with my EC2 instance. Okay, so it is connected. So I have selected the Ubuntu OS. So it is showing me the Ubuntu OS. Okay, let me check the path. So home Ubuntu. Let's clear the screen. Okay. I have to implement the Spring Boot application, which is a Java-based application. So I have to check the version of the Java here installed. So it is showing me that no Java is installed. So I have to install Java. So first of all, I have to update this machine. Sorry. It will take a couple of minutes to update this EC2 instance. Okay, it's updated. Now I have to install the Java. Sudo install JDK 17 JDK. Okay, in my application, I'm using the Java version 17, so that's why I'm installing Java version 17 on this EC2 instance. Okay, so it's installed. Let me clear the screen, check the Java version, Java hyphen version. So it is showing me that it has installed Java 17 version. Okay, now I have set up my EC2 instance. Now I have to upload my application to the S3 bucket. So as I've told you that S3 bucket is just simple a container where we can save our objects. So here in this application, I'm creating one jar file, or you can say my build file. So run and Maven install. It will create a jar file for me. Okay, build success. It has created. So let's refresh it. And in the target folder, I can see it has created one build file, the jar file, spring on aws.jar. Okay, so now I have to implement or deploy this jar file on my EC2 instance. Okay, for that, I have to go to the S3 bucket. Okay, so this is my S3 bucket. So let me create one bucket. So I'm creating it in the Mumbai zone. My PLC bucket, and I'll make it to be accessible publicly. Acknowledge it, and yeah, then create the bucket.
A quick question on that. Does it need to be available publicly?
Actually, I will be getting no. You can make it private also, but there are means I have to access that on the EC2 instance, so I am making that only.
Okay, so just for simplification, but I mean, like you could make it accessible via EC2 even though it's private, right? Because if it's on
Yeah,
the
yeah,
same
correct.
VPC or okay,
Yes, yes, yes. So for the simplicity, I am doing this.
okay.
Okay, so I have created my bucket. So here is my bucket. Let me go inside the bucket. Uh, and go to the permission. I have to create one bucket policy generator. Get object. ARN, actually it is the AWS resource name, so I'm using it that I can access everything from this bucket. Add statement, generate policy. Uh, yeah, so here I'm set. Okay, so here in this bucket, we can see that we don't have any objects. So I will be uploading my application here, add files, and I will be uploading my jar file.
Just a question. By creating
Yes.
policy, what you achieved?
So by creating the policy, I have made this jar file accessible to from everywhere. So like I will be accessing this from the EC2 instance.
Okay. If you don't
I
do
will
it
be
here, then
downloading.
if you don't do it, then there is there any other way to access from EC2?
Yeah, there might be a way, but
Okay.
using this way, I select it.
Okay.
So succeeded. Okay, close. So it will give me one URL. So with this URL, with this object URL, I can access it from anywhere. That's why I have put that policy. That policy can be is configurable. You can configure it for your own desire. So I have copied it, and here I have pasted it. So ls. So from the S3 bucket, this jar file is in my EC2 instance. Now let me run it. Minus jar spring. Okay, so my application is up and running. It is on port 8080. Now, how can I access it? So for this, I need to go to my EC2 instance. It gives me two things. I can access it using the public IPv4 address, public IP, or I can use this DNS also for accessing it. So let's access it using this IP address.
Umang, to answer to your question, we can make the bucket as a public and we can access it, but it is not safe. So we should always go with the secure way.
Private, yeah.
Okay.
So my jar file is my Spring Boot application is running. So let's access my endpoint. So here I'm using the Chat GPT API. So I can ask anything from here like uh, what is AWS and its services. Spelling of services wrong. Services. Yeah. So from using the Chat GPT, it has given me the output. Here I can ask any other question also. Describe Spring framework and its components. So Spring framework is one of the most popular, and here it has given its components also, IOC container and everything. So like this, I have deployed my Spring Boot application to the EC2 instance. And yes, if we use the private one, our objects will be secured. So my next demonstration is on uh, Elastic Bean Stack. So I will be deploying the same application on the Elastic Bean Stack. So what is the difference between EC2 instance and Elastic Bean Stack? So actually Elastic Bean Stack in the when I have used the EC2 instance, so I have created one virtual machine as a EC2 instance, and I have used the S3 bucket and everything. But here in the Elastic Bean Stack, it will give me the whole environment. It will by itself give me the whole environment where I can uh, deploy my application. So let's move on to that. Okay, let me close this. Okay, once it is used, I can stop this instance. Next, we will go to the Beanstalk. So this is our Beanstalk service. So as it says, Amazon Elastic Beanstalk is easy to use services for deploying and scaling the web applications and services deployed with Java, .NET, PHP. So it gives us various environments for .NET, also PHP and Python. So we'll take the use case of the Java application. So here I have to create one environment. So web environment, application name, my PLC application. Then it will create the environment for that. Then here is a domain name. We can, if we leave it blank, then it will be auto generated, or we can provide our own, like Rama and anything like that. Then this is a managed platform that on which for which platform we are going to deploy. So here we have lots of options for .NET, Docker, Node.js, PHP, Python. So I'm selecting Java and 17. So for application code, I can run the sample application here also, or I can upload my code. So here also we are given two options. First it will ask for the version. So we are given two options. One is the local file. I can upload from my local machine also, and I can use the S3 bucket URL also. So I will upload it from my local machine. Okay. So I'm using the free tier single instance for this. Here I have already created one role, my PLC AWS profile. Selected the default VPC public access for all zones. I'm not using any database, so I'm not selecting anything here. Everything I'm leaving as default. Okay, so here is a security group. So as we know that security groups are like firewalls. It gives us it allows the traffic to flow inside the instance. So I have already created one security group here. Here we have metrics for the CloudWatch. I'm leaving everything as a default. Here I'll add one environment property. Is server underscore port. So it has come to review. So after review, I'll submit it, and it will start creating the environment for me. So as I told earlier that when it is launching this Elastic Bean Stack, so in the background it is doing everything, like it is creating the EC2 instance, it is creating uh, 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 the S3 bucket, everything it is doing. So we can check this in the EC2 dash here in the cloud. Here we have another service, Cloud Formation, which runs in the background. So here in the event, we can see here that it is creating the bean stack instance. Everything it is showing here, and then we have one more feature of the template. We can view that is view in designer here. It will show what structure it is creating. Yeah, here. So it is showing that what structure it is going to create. So once it is completed, apart from that, we can also check uh, EC2 instance, EC2 dashboard also. Like here, it has created one instance. And like this, one Elastic IP it has created. So these things it creates automatically in the background. We don't have to create that. It is the environment is successfully launched. So if we have another version of the same application, we can choose from here. We can give another version label and we can upload that. So let's check whether our application is running or not. So it is the domain. We can click it and check whether it is running. /chat/pod question mark prompt. What is Elastic Bean Stack? Okay. Okay, I have given the wrong URL. Now it should run. Okay. So here it has given the response. Elastic Bean Stack is a platform as a service offered by Amazon Web Services that allows developer to quickly deploy and manage applications in the cloud without the need to worry. So here also it is accessible. Now my next demonstration. Next demonstration is on AWS ECS. So first of all, I will not be using any Docker Hub or S3. I will be using the ECR, which is the Elastic Container Registry. It is like the Docker Hub where we can save our images and we can fetch our images in the ECS. So what is actually ECS and AWS Fargate? So these are the two services. AWS ECS is a containerized orchestration service. So we use it either with the AWS Fargate, which is a serverless compute engine for the containers, or we can also use it with the EC2 instance. So the main advantage of this ECS is that we can deploy our microservices or containerized application with the ECS, and we don't have to worry about the auto scaling and auto scaling thing. Means when the we can add alarms, and we can add checks, so that whenever there is some load on the server, then automatically the Fargate or EC2 containers will get automatically increased, scale up, and when the load is down, then it will get decreased. So let's check it. So so what I did for deploying it, what so it is a containerized service, so we have to make means we cannot deploy it like this. So I have created my Docker image for this Spring Boot application, and then this Dockerized image I have put it into the ECR, Elastic Container Registry. Then in this from this Elastic Container Registry, I have fetched this into the ECS, where I will be using the AWS Fargate for deploying this Spring Boot application. Okay, so let's uh, go to our applications. Okay, we can terminate the environment here, or we can do it later. So here I have already created my repository for that. We can also create a new repository. It can be a private and it can be a public. And if means if it is private, then with the proper IAM access, it can be accessible. But if it will be public, then the same case is like the S3, means anyone can download it. So we can make it private, and we can create our repository. So I have already created that. Where I have put one image. So in our Docker application also, I have created one Docker image for that, and I have already uploaded that for saving the time in the presentation. So
By the way, how did you upload that? Did you just manually do that or via command line or?
no, actually, I have manually did that. I have I first I have created this Docker image, and after creating this Docker image, I have pulled that image into that registry. But we have various ways for pulling that into our EC2 instance. Like we can use the CI/CD tools also. Like we have Jenkins, and in the AWS also we have services by using which we can upload our means we deploy our code, and once we deploy our code, once it gets refreshed, everything all the latest code gets deployed into the ECS. So we can also do that, but for this case I have just manually did that, and I already did that, so for saving the time in the presentation.
Okay, cool.
So
Thanks.
yeah, so here is my latest image. So here is the URL which I will be using. So I have copied it, and here is my Elastic Container Service, which is for containerized applications. So first, what we have to do, we have to create the task definition here. So we can come here and we can create a new task definition. Here I have added one task. Here we have two launch types. We can do infrastructures, like we can use the AWS Fargate, or we can use EC2 instance also. So for this case, I'm using the AWS Fargate. So why I'm using the AWS Fargate? Because it is a serverless compute for the containers. Means it is serverless means means we just have to pay only for this the containers which we will be using. If we are not using anything, then we do not have to pay. It is just like the AWS Lambda. Here I'm choosing. Then here we have to define our container. So and here we have to give our image URL. This image URL we can fetch it from the Docker Hub also, or we can give from the our ECR, our container registry also. I'm mapping one port because I will be accessing it on the port 8080 and HTTP only. Here we have some setups for the CloudWatch. CloudWatch is also a very good service for checking the logs of our applications, of our instances. It gives a very cool dashboard for checking everything. We can set the alarms also. Monitoring. Okay, let's create this. Okay, so the task definition is created. Now we can have multiple tasks, and we can, after creating those multiple tasks, we can create cluster, and inside that cluster we can implement that. So here I'm for this task definition, I'm creating one cluster. My PLC cluster. Again, I'm using this serverless AWS Fargate. Okay. Created. While it is creating, we can view its logs and events in the cloud formation also, that what it is creating. So here we can see in the cloud formation its events, what it is creating in the background. Okay, so it has created one cluster. Let's go inside the cluster. Here we can see that there is no task running, so let me add one task. So the task which I have created, existing, I'll use my own security group as a firewall. Volume I'll not add, I'll rest everything default. Create. Okay, so it is in the provisioning state. So it will take couple of minutes to get into the running state. It will when it will get to green. Now it has changed state to the pending. Yeah, now it is running. Okay, let's get inside the cluster. And here we have its public IP. Hold on, 8080 /pod/chat question mark prompt equal to what are the advantages of AWS Fargate over EC2. So it will use the ChatGPT API to get the answer, like serverless architecture. As I told that AWS is a serverless, so we get this advantage is scalability, security. So these are the options. So this is the last demonstration. Now uh, it's time for questions. So you can ask questions.
I don't think I have any questions, but just wanted to say great job. I really love this. This was some good work and some things that we can all learn. We all need to be up to
Thank
date
you
on
very
these
much.
things.
Actually, from means I would like to thank everybody because from the last 1 month I'm learning AWS and everybody here is helping me in learning the AWS. Means before joining Prama, I just know the full form of AWS, but I think now I know a lot of things. I need more brush up.
Do you have this documented anywhere? Like it seems like we could have like a tutorial where we could have people actually go and do this themselves so that they could also learn what you've learned.
Actually, when let me share my screen. Actually, when I was learning this AWS, I was creating one documentation for myself only for clearing some interviews. So I hope this might be useful for anyone. So here,
Oh yeah,
like
yeah, this is definitely
this,
if nothing else, this is just a really good start. So
yeah, like region, what is a region, what is availability zone, what is IAM. These document I created it. I have not created it completely because right now means I have not completed all my whole course, but this I have created. So I can share
cool.
that.
Yeah, yeah, thank you.
So anyone else who want to ask question or please give me suggestions so that I can improve myself.
No, it was quite good presentation. At least I'm not from AWS background, so at least for me it was understandable.
Thank you.
All right. Anybody else has any suggestions, feedbacks, tips?
Oh, sorry, I
I
have not seen the chat. Thanks for the session was in dropping of the call. Okay.
All right. Thank you so much, Mohsin. It was a wonderful presentation. I believe
Thank
many
you very
people,
much.
many people might used it in their projects and might be helpful for many. Thank you all for taking this time and Friday evening and joining the PLC and supporting.
Yeah. So
It was great.
happy weekend to all of you.
Yeah. Thank you all so much. The recordings will be available soon for those who could not join and for anyone else's references as well. Thank you, guys. Happy weekend.
Yeah,
See ya.
Okay,
thank you.
thank
Thank
you.
you.
Thank you.
Thank you. Good night.
Guys. Thank you, Mohsin.
Thank you.